Okay, so welcome to this cryptography second video. So basically now I'll be looking on cybersecurity first year test 1. So keep in mind this is applicable for cybersecurity first year and ICT students third year. So now what I'll actually do for this video is that it will be divided into parts. So each question will be a video. So for this one, it's part 1, and a playlist to be created and it will be added at the end of the video so as to complete this test 1 paper. Okay, so the instructions were simple. Do not turn this paper until you are told to do so. This question contains 5 questions. Attempt 4 questions. So basically it means 4 videos will be created, because the last question is just some explanations, and I'm not doing that because you can just start on your own. So write your name, student ID and program clearly on your answer sheet. So that was part of the instruction. Time allowed is 2 hours only. Only calculators allowed in this exam, so we can use calculators. So let's start now. Okay. Question 1. A. Using a Caesar cipher with S is equals to 5, decode the received message, which is this. So basically in the first video for cryptography, I talked about Caesar ciphers and how to do them. So here I'll be straight on point. So for question 1A, here is the solution. So basically you need to write the alphabet from A up to Z for it to represent the plain text. Then since they are saying the key or S is equals to 5, you just need to count from A 1, 2, 3, 4, 5, meaning from A up to E, that's your 5. If you remove these, it means that you start from F up to Z, like that. So if you start from F up to Z, you realize that you need to start again because you're wrapping around, meaning you have A, B, C, D, and E. So that will represent your cipher text. The cipher text, and as we know, S is close to 5 with that shift. Okay, now that you have that information, what you need to do is that you need to get the plain text, which is given in the question, or which is not given. In our case it's not given because they're saying we need to decode or to decrypt that cipher text. So that message is a cipher text. So I'll write it down, so I'll just pause the video. Okay, so this is our cipher text, or the message we need to decode. So based on this sequence we have created with this key, we just need to follow the order. So since this is the cipher text, our concentration will be on this cipher text. So we have Y, so we go where there's Y, so I can see Y, then above there's T. So here I'll just put T to represent Y. Then we have M, and as we can see here we have M. Okay, so just a minute. Okay, so as you can see here we have M. So where there's M, just above we have H. So there I will say H. Then as you can see N here, so N above we have I. So I'll say I. Then where there's X, as you can see above there's S. So you can lead that like this. So this can be converted or decoded to create what we call this. Then you just continue with this same process. So just pause the video, since now you know how we are doing this. So basically we just need to continue with that. I don't know why my case is stopping working. Okay, so Okay, so finally, as you can see, from our cipher text, you are getting a plain text which is saying this test is interesting. So already the test is interesting because we have managed to decode and read the message. Now going to the next question, which is B. Using Caesar cipher with S is equals to 3 and S is equals to 7. Encrypt the message welcome to cryptography using this sequence. So I'll pause the video so that I arrange some things first. Okay, so this is our plain text, and they are saying that the first key is S is equals to 3. So I'll count 1, 2, 3. As you can see, if we remove A, B, C, we can start at D, then up to here, Z. Then after that, it will go under that. Then we can wrap around with A, B, C. That's all. So now, this is basically to represent S is equals to 3. And the question goes on by saying S is equals to 7. So if S is equals to 7, what we need to do is go back to that plain text. So we count up to 7. 1, 2, 3, 4, 5, 6, 7. So it means this will be removed. Then we will start at H up to Z, then we wrap around. So I'll copy that, then we can start wrapping around A, B, C, D, E, F, G, like that, to represent S is equals to 7. So if you understand that now, we can follow their question, which says we need to encrypt the message welcome to cryptography using that sequence. So first of all, we need to understand the sequence. So that is the sequence now I'm writing. So here's the thing first. I'll write even the plain text, then the cipher text we're expecting to get. So after that is done now, we can write the plain text which is welcome to cryptography. Okay, so as you can see, our plain text is welcome to cryptography. Now, the sequence we are given from following that question, where there is W or the first letter, I'll say C1 because that's how the sequence is going from this question. Then following C2, as you can see, again we have C2, again we have C1, then lastly C2. Now, since this is our sequence, so what I'll do now is I'll repeat this same sequence. I'll repeat the sequence the way it is. So since we ended at C2, it means that, okay, let me put this in no order first. Okay, so now as you can see, this is the sequence. So this sequence will be repeating on this cipher text like this. So now if I repeat this sequence, you can see that I'm trying to make them fit on each coming later. I'm just repeating the sequence the way it is. Then okay, so basically I've repeated this sequence on this plain text. Now this sequence will help us to come up with our cipher text. So from this, the first sequence we created for S is equals to 3 is what we are calling the C1. Then C2 is represented by this shift which was given by S is equals to 7. That's the one which is representing C2. So with that sequence now, we can come up with our cipher text which we need to get for this answer. So now that we have that information, we can start. So we have W to represent C1. So in the plain text where there is W, I'll go down where there is C1, so it's Z, like that. So I'll start with a Z. Then for E, where there's E from the plain text, I'll go to C2 because the sequence is under C2, so it will be L. So I repeat following the sequence. So where there is L, I'll go where there's L, then the sequence is saying C2. So down where there's C2, it's S. Where there's C, the sequence is saying C1, so it's F. So you put F. Where there's O from the plain text, the sequence is saying C2, so it's V. Then where there's M, the sequence is saying C1, so it's P. Then where there's E, the sequence is saying C2, so it's L. Then that we are done. Now we have T. Where there's T, it's saying C2, so you just go down, it's A. Where there is O, the sequence is saying C1, which is V, O, which is R. Then we have that. So C, the sequence is saying C2, which is J. R, the sequence is saying C1, which is U. Then Y, the sequence is saying, where is Y? Oh, the sequence is saying C2, which is F. Where there's P, the sequence is saying C2, which is W. Where there's T, the sequence is saying C1, which is W again. Then where there's C, the sequence is, where there's O, the sequence is saying C2, so which is V. Where there's C1, where there's G, the sequence is saying C1, which is J. Where there's R, the sequence is saying C2, which is Y. Where there's A, the sequence is saying C2, which is H. Where there's P, the sequence is saying C1, which is S. Where there's H, the sequence is saying C2, which is O. And finally, where there's Y, the sequence is saying C1, which is B. So from that, it means that we have officially encrypted or obtained our cipher text from that plain text using the sequence. So that was it for B. A little bit tricky but very simple. So let's head to C. C, the centurion who was supposed to inform you of S was killed en route, but you have received the message, that which is a cipher text or encrypted message in a Caesar cipher. So you can see this was encrypted using a Caesar cipher. So find the value of S and decode the message. So what they are telling us is we need to decode this and find its key. Now hint, use brute force. Okay, so for question B, as you can see, I've done everything without pausing the video because this is the first time talking about that. So next time will be fast. So for brute force, because the first time, I'll teach you this simple method I actually use to crack certain messages. So now here is the thing. You need to know the given cipher text first. So let's do that. Okay, so for this question, I'll show you three methods. So let's start with my favorite. So in a case whereby you are given a cipher text but you don't know the key and the plain text, you need to go where your cipher text is. Then you ask yourself which letters are actually fewer than the others so that I can try to crack that small word. So in a case whereby we have this cipher text, we can see that UE is the one with a few letters. So our target from that cipher text will be UE. So will be UE. Then let's try to come up with the suggested plain text for this UE from any English words. So number one, we have something like if. So those are just two words. We have is, or, and so on. So for now, I'll just list this so we can start trying them out. So if we have if, I'll get my normal alphabet, then try to crack that. So if we have if, it means that where we are seeing I should correspond with U. So I is from this plain text, as we can see. So I'll go where there's I, which is here. So where there's I, right there, I need to put U. So I should correspond with U. So I'll put U. Then F should correspond with E. So where there is F from this alphabet, I'll put E. So as you can see, E. So just like that. Now, having that information now, I'll try to follow the normal sequence of the alphabet. If it works out, it means that this thing is actually correct. So here is how to detect that. So we have E. If we go above, we say F, G, H, I, and you can see this is U, not I. So here's the thing. I have this, which is E. So above E, we have F. So I'll say E. What's the following thing after E? It's F. So E, F, G, H, I, and this is U, it's not I. So this is wrong. So we can see that if is not correct. So now let's try to work out with is. Okay, so where there's I, we put U. So where there's I now is where we put U, like that. So where there's I, we are having U like that. And now where there is S, because we are dealing with is, where there is S, okay, where there is S, we need to put E. So where there is S from here, which is here, we need to put E. So where there is S, we put E. Now from that we can try to follow this sequence. This is U, V, W, X, Y, Z, A, B, C, D, and you can see this is E. From that you can tell that this sequence is correct. So let me even finish it up. U, V, W, X, Y, Z, then A, B, C, D. As you can see, yeah, let me do like this. So you know we are starting at U from I. So I'll do this. U, V, W, X, Y, Z, A, B, C, D, E. As you can see, E is straight with S the way we wanted it. E, F, G, H, I, J, K, L. So now because we have reached Z at L, we need to start from A, L, M, N, O, P, Q, R, S, T. Since we have U, so I'll just combine these two. So you can see now we have this plain text and this cipher text. So let me now indicate that. So this will represent plain text, as we know, and finally why is my case up here for me? And finally this will represent the cipher text, which is just at the bottom there. So as you can see, cipher text. Okay, now since we have this information, we can actually decode this message. First, let's come up with our key. Remember what we said about the key, how to find the key. You just need to ask yourself, how can you make this shift of M? So I'll say 1 2 3 4 5 6 7 8 9 10 11 12. So from A up to L, this was removed. Now we started at L going this side, so it means our key is 12, or S was equal to 12. Since they're saying find, we need to find the key, which is S. So the key, we have found that, which is 12, and we have that order. So now that we have this information, now no wonder it's brute force. We're trying many possible ways to decode this message. So now let's do this. We have M from this cipher text. So M is corresponding with A. We put A there. Then we have X from this cipher text. So corresponding with L. So wherever we see X, we put L. Now we have S, which is corresponding with G. We put G. Then we have M corresponding with A, G corresponding with U, then X corresponding with L, then U corresponding with I, E corresponding with S, like that, because that was our suggested plain text is. Then P corresponding with D, U corresponding with I, H, where is H, corresponding with V, U again corresponding with I, as we said, then P, as we said, corresponding with D, Q corresponding with E, and finally again P corresponding with D. So we can now read these as OGAO is divided. It's even making sense. So we have decrypted this message, which was given by Mr. Chishala in this test. So now that we have done that, this is the first method. Let's try out another method. So in another method is what we call frequency analysis. So frequency analysis. So for frequency analysis, what we are doing is that we need to detect which letters from this cipher text is coming out the most. As you can see, we have just one M, we have 1, then 2. So M, we have 2. M, we have 2. So if it's just repeating once, don't consider it. For X, we have 1, 2, 3. So X, we have 3. Then we have S just coming once, so we'll leave that. G just once, we leave that again. Then U, 1, 2, 3. So U coming 3. Then we have E just once, we leave it. P, 1, 2, 3. So P again 3. Then we have Q just once, H just once, we leave it. Okay, so we have those letters which are coming frequent, known as called frequency analysis. Now from that, we know that the normal alphabet starts from A going to Z. That's your first step. We do that. Now since this is M, M is equals to 2, like M is repeating, so forget about the numbers, we are concentrating on M. So because M is repeating, I'll just start M, then what follows? N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Then A, B, C, D, E, F, G, H, I, J, K, L, M. Just L, because we already have M and have reached Z. So that's for M. So from that, we can just go to our cipher text. So you can see M corresponds with A, that's that. Then X corresponds with L. You can see those are L. Then you finish it up, you realize that you have the same sequence. Then you decode the message and you can know the key. Now, in a case whereby you want to find the key of the formula, since we are given the cipher text, like we are given the cipher text, which is cipher text is equals to encryption algorithm for a given plain text plus the key, then mod 26. Okay, so what this means is that our cipher text for that, like let me say M is corresponding with what? A, and we know that A is what we are calling 1, so A is 1. Then the key we don't know, which is just K, so in our case it's S because we are saying find the value of S, then mod 26. Now C, which is the cipher text, because it's M, is on 13 from the alphabet. So now if we have that information, we know that in normal mathematics that other number will go to the other side, which is positive, to become negative. So it will be -1 should be equal to S. Then we are forgetting about the mod because the answer is less than 26. So 13 minus 1, that's 12. No wonder S is equals to 12. So that's another way you can find that key. Now with frequency analysis, if M didn't work out, you need to go for X. So where there's A down, you put X, then Y, Z, A, B, whatsoever you continue. So from that now, it means that second method we are done. So the last method, which is actually complicated, don't use it, it wastes your time. This is just 10 marks and we have already solved it. So it's like this. You need to repeat the alphabet with a shift from 1 up to a shift of 26. So if the first one was the plain text, the first shift will be if S is equals to 1. So what we do is that we will start at B, then C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, A. Then now if that is done, we'll go to the sequence which is having C. So we just do that, then A, B. Now from that we need to start at D. So I hope you are following what I'm doing. We are starting at D, then we say A, B, C. Okay, then from that we need to start at E. So again, I'm waiting for my case. I don't know why my PC is performing. So we start at E like that, then A, B, C, D. Okay, then we start at F now. So till you reach Z, you start at F like that. A, B, C, D, E, F. Okay, so not F because we already have F. So I'll do that. Okay, so now we need to start at G. So let's do that. A, B, C, D, E, K, F. Then we are going at H. Okay, now that you know what I'm doing, I'll just pause the video, then finish everything. A, B, C, D, E, F, G. Okay, so let me pause the video, then finish the sequence. I'm even tired. Okay, so now this is what I mean now. So if you have this, it means that from your cipher text which you are given, you are trying to decode. This is where now you start trying it out for each of its sequences, starting from here going down to see if it can crack this. So in our case, this was the correct sequence starting at M. So it means you could have done these tries So to reach here, you could have done all these tries for you to actually decode the message using this. So basically this is now what we call a brute force, because we're trying many possible ways for you to decode that message, just to know that the shift was s is equals to 12 and it was just saying oh girl is divided. Okay, so this is Soko James, tutor for KMU cybersecurity tutorials. So see you in part 2 of this video. So this was part 1. Just make sure to click the playlist at the end for you to watch solutions for question 2 to represent part 2. So thank you for watching, guys.